So this first example is a nice simple ring bracket. You can see there's a few different things going on already, even on this simple part. So on the top here, we have this kind of donut ring, and that part is woven. We can see that we have this like conformal zigzag type geometry here. And on the base, we have a completely different style of weaving. This is all done within the slice operator. And we can see here that we have two parallel weaves running side by side. We have a controllable overlap between our weaving patterns. We can control the overlap between the welds of the weave itself as well, plus many other things. So we have that nice example here. And for the next one, we have this kind of fork geometry of a bracket here. And we have one direction of weaving and completely different direction for all these elements here. And this part was pre-segmented in CAD. So this is an example where we're using a predefined geometry to split the geometry up. But we also have an example later on that shows that we can also do it completely automatically as well. For this next part, this is using our revolve slicing mode. So this is slightly different, and we've had the weaving in revolve for a short while now, but it's definitely still worth talking about as it's related to what we've been talking about now. So you can see here we have lots of different weaving rings. It's just a nice example to show that we can automatically generate the number of rings necessary based on overlap conditions within the boundaries that a user can set, so that they don't ruin their print with bad toolpathing based off pre-assumptions or limitations of software. Here, the number of rings generated is based on what the user needs in order to print the part. This next example here is a relatively complex bracket. So once again, we have this main body section here, these bits that come out, they've got their different weaving directions and this different element on here. So we don't have to draw like a bird's eye view and say, okay, I want this section here to go that way, and these are all completely different. We do it based on complex geometric algorithms, and it will work on different parts of the geometry depending on their actual geometry. So this section here is a completely different direction to this section here. I don't have to draw over, filter lots of different layers, and do a very manual process. Instead, the part can either be simply predefined, pre-segmented, loaded in, and use those different sections to automatically generate your weaving direction. Or, as I've hinted at a couple of times now, we can also do it automatically. Here's another good revolve example, which is non-planar in this case. So you can see our layers transforming from horizontal to non-planar. So another good example here of these kind of complex geometries using weaving. For this next section, this shows that we can combine different strategies together on a single part. So the final part is this section here. So you can see on the main parts of this frame, these have all been woven. We've got these flowing weaving patterns here. We've got different segmentations going on, and this can be done based off, like I say, part segmentation, or in the automatic mode, you can specify what your conditions are for different segmentations of regions here. And in this case, this bulky area here, for whatever reason, we may not want to weave in it, we may want to use a different strategy. That's exactly what we've done here. We can select your different regions or filter them out in whatever ways you need and apply completely different printing strategies, different process parameters, and treat them as a single print. So here we can print them all layer by layer or in some other sequence if we wish to as well. And this final example I have for you today is another great example, and this time it is fully automatic. So we can once again use different regions to print parts of completely different settings, different process parameters, slice them in different ways. And this region here, the like orange gold infill region, this was done fully automatic. So very impressive. We have this complex kind of funny shape in the middle, and these weaves have been geometrically determined to be printing this way with the settings that we've used. See here we have a weave going into a stringer and then going out into another weave at the end because the profile of that part of the geometry is changing. So this can save huge amounts of time, labor, trying to split CAD files up or split toolpaths up, trying to find the best way to maybe print a part. Aibuild, we can do it all automatically. This weaving functionality is brand new, and we'll be rolling out to other slicing modes. We have it in our planar slicing modes right now. We'll also be adding it to things like radial and non-planar. We'll also be working on more automatic segmentation of your parts. So this is a really nice upgrade for DED users, for wire arc users, and anybody else that is interested in weaving.